Well, hello, everyone. Welcome and thank you for joining today's webinar titled Capturing Hard-to-Reach Assets with Decimeter Accuracy. My name is Mark Goldman. I'm the Director of Architecture, Engineering, and Construction Industry Solutions at Esri, and I will be your facilitator for today's program. Now, Esri is the largest location intelligence and digital mapping technology company in the world. Our solutions help architects, engineers, general and specialty contractors bring a geographic context to the engineering projects and design projects they're working on. We ensure access to the most up-to-date data by all stakeholders across all stages of projects of all sizes and complexity. And through our location intelligence solutions, we're providing context and geo-enabling AEC firms. We're helping firms devise improved workflows, allowing them to build smart communities and assets for the future. Today's topic, capturing hard-to-reach assets with decimeter accuracy. It's one I find very interesting. As an AEC professional, over the years I've worked in architecture, I've worked in engineering, I've worked in construction and facilities management, but I've never worked in the field as a surveyor. I've never had to contend with the complexity of documenting existing conditions in challenging situations. So any opportunity to better understand how other AEC participants get their work done efficiently and accurately, I'm eager to be part of. So with that, let me introduce our team today. Joining us today are Doug Morgenthaler with Esri, Sarah Albin with EOS Positioning Systems, and Mike George with DDSI. Doug Morgenthaler is a product engineer group lead at Esri. He's the product owner of Collector for ArcGIS. Our second presenter after Doug will be Sarah Albin, and she's the head of marketing for EOS Positioning Systems. She formerly worked at Esri and at National Geographic. And our third presenter, a little bit about Mike George. He is the GIS director and project manager at DDSI Global. DDSI provides geomatic services to the oil and gas, the telecom, local government sectors. Mike is also a licensed UAV pilot. So with that, I'll go ahead and turn it over to you, Doug.
Thanks, Mark. So I wanted to talk to you just for a few minutes about Collector for ArcGIS. Collector is our premier field data collection tool. Collector is a configurable mobile app that supports a wide variety of workflows and industries. It supports two primary workflows: capturing new assets or visiting or inspecting existing assets or observations. Little or no internet connectivity is still, unfortunately, a reality for many of our data collection projects. Collector has a strong support for occasionally connected or fully disconnected workflows to ensure that you can complete your work anywhere or anytime. High accuracy is a key capability for many AEC workflows. We support a wide variety of GPS receivers, including the EOS Arrow line of GNSS receivers. We do support a wide variety of correction sources that may be using RTK or satellite-based corrections to achieve up to centimeter accuracy in real time, no post-processing required. We also support additional capabilities to collect more accurate information for more specific workflows. One of those we'll be talking about today. And this is really what we've seen is that Collector over the past few years has started to be used in more workflows where you may have traditionally seen those being done by traditional surveyors. So this just highlights a number of different aspects where we see Collector being used today for common engineering and construction workflows, such as site planning, ground control for aerial imagery collection and georeferencing using UAVs or UAS, validating design decisions before construction begins, or accurately capturing as-built assets once construction is underway or it's been completed. Collector allows you to engage your field workforce to capture this information to achieve the spatial accuracy that you require for your particular project. So Collector is just a part of our larger field operations suite. Esri's field operation apps allow our customers to perform common phases of field work. And ArcGIS is the thing that ties all of that work together. Using the power of location, you can improve the coordination and operational efficiency in your field workforce activities. You can reduce or replace your reliance on paper-based workflows. You can ensure that both field and office use the same authoritative data to reduce errors, boost productivity, and save money. So this is just a slide outlining some of the other apps that you may use to complete those workflows. Each of these apps can be used independently but they can help or be used one or in many together. That can improve the efficiency of your larger field data collection or acquisition processes, improve the visibility of ongoing activities by monitoring that as it progresses, and also aid in sharing that information and delivering that to your project stakeholders or customers. As Mark mentioned, there are a lot of environmental challenges to capturing data accurately in the field. So some of those examples may be areas where it's hard to reach due to safety reasons, or your environment is challenging. Maybe you're working under dense tree cover, or you're in a built environment where you've got lots of tall buildings that are interfering with the quality of the GPS signals that you're getting. We partner with EOS and LaserTech to support additional capabilities and workflows to ensure that you can collect highly accurate information quickly and safely in these types of difficult environments. At this point, I'd like to turn it over to Sarah to talk about EOS positioning systems and the laser offset capabilities.
Thank you so much, Doug. EOS Positioning Systems is an Esri Silver partner, and our technical team was credited with creating the world's first GPS receiver that is Bluetooth capable. It can work on any device, and it achieves a centimeter accuracy. What you see on the left is actually two of our most popular receivers. You've got the Aero Gold, which is a centimeter unit, and the Aero 100, which is our submeter unit. On the right, you see a video from one of our customers. This is made by a guy named Frederick at the Port of Auckland, and I'll go into a little bit of detail about what Frederick is showing us there. Before I do that, I want to address that GPS and GNSS might both be used interchangeably in this webinar, but GPS could be considered like the US brand of GNSS. Those are the positioning satellites that the US government launched. You also have GNSS satellites from Europe with the Galileo satellites. You have the Russian satellites from GLONASS, and you have the Beidou satellites from China. Most of today's advanced receivers can access or lock onto satellites from all of those constellations. So what you're seeing in this video here, that blue dot actually represents the antenna that you see in the video portion. And that antenna is receiving your GNSS satellite positioning from the GPS, the GLONASS, the Beidou, and the Galileo satellites. That initial position is being further corrected down to the centimeter level of accuracy through an RTK connection. And you might have caught a glimpse of the EOS Positioning Systems app, which is EOS Tools Pro, which is just a free app that's allowed Frederick to connect to his local RTK network. And what he's doing here is pretty cool. His position and the satellite signals are being captured by the antenna, or rather received. They're being cabled into his Aero Gold receiver on that range pole. And then all of that location is being Bluetooth sent to his iPhone, where it can be captured and used in Collector, which is what you're seeing on the screen. And so you can see where his dot is right on the corner of that yellow rectangle in the real world. And it's pretty cool because now he's going to move it to the other corner of the rectangle, and that's moving with high precision in his Collector. He can communicate directly with the engineers back in the office that the stuff happening in the field matches the designs that they have. Because so many of our customers choose to use Collector and iOS devices, we release a lot of solutions to work with those technologies. 2 years ago, we released the world's first laser mapping solution for Collector on iOS. And this was actually the result of a three-way partnership between EOS for the GNSS or GPS, with LaserTech for the rangefinders, and with Doug's Collector team at Esri. The solution allows you to capture an asset, whether it's a utility locate, an irrigation valve, something that you don't want to physically stand on top of in order to capture it with high accuracy in real time. So some situations that Doug alluded to where you might want to do this, you can imagine if it's an unsafe environment, like you've got a manhole in the middle of a street and you don't want to send a field crew person to stand on top of that, or you might just have an irrigation valve that's underneath heavy foliage and you can't lock onto satellites when you're underneath it. You could also imagine this working in downtown Manhattan, where you've got a lot of buildings and you would prefer to stand in an area where you have open skies and just shoot your asset from afar, but retain that centimeter level of accuracy. So what you're seeing in this video is Tyler there is going through one of the workflows that Mike George, the next presenter, used in some of his use cases. He's going through a workflow we call the range workflow. And what it means is that he's going to stand on his initial control point, just take the location of where he's standing. Then he's going to shoot his asset. That asset might be a manhole, let's say. He's going to move to a second control point. And while he's doing this, EOS Tools Pro, which is what you see on the right side of that screen with his iPad that's showing, is going to walk him through those steps. When he moves to his second control point, he's going to do the same thing. He'll take the location, he'll shoot the same exact target. So in this case, we're imagining it's a manhole. And then EOS Tools Pro is going to provide him an option for, based on the control points he's taken and the target that he shot, which of the 2 points represents the location that he wants to log in Collector. So you can see it's calculated 2 possible points where those intersections are. He's going to select the one that represents his target in the field, and then he's going to send it through to Collector by setting the send button, and it goes straight through Collector to ArcGIS Online. There are actually a couple of other workflows that people can choose from. There's range backsight is good if you want to stand in one spot, calibrate once, and be able to shoot a lot of points. Range azimuth is good if your field crews have to be agile and speedy. All of them have slightly nuanced setups to how you would use them in the field. On our website, you can find more how-to articles, how-to videos like the one you saw, and the specifications for the field gear. But now I'm going to pass it over to Mike George. Mike is a project manager with DDSI, and they do design, drafting, and surveying. They were one of the earliest adopters of this laser mapping solution.
Perfect. Thanks, Sarah. Well, first off, I just want to say thank you to Esri and EOS Positioning for putting this all together today, and a special thanks for all of you attending our webinar. As Sarah mentioned, my name is Mike George. I'm one of the project managers here at DDSI, and I've been in the geospatial business for almost 21 years now. I started off by mapping trails and jeep roads here in Colorado for use in future Forest Service management plans. And I pretty much one way or another been involved in the field data collection side of the industry for the majority of my career. So here's the agenda that we're going to be going over today. We're going to talk a little bit about the technology that was employed. Going to highlight 3 case studies where we've recently implemented this new workflow, where we are applying all this new high accuracy technology, and then some examples of how we're pulling it all together with GIS and CAD. So just a quick summary of our company. As Sarah mentioned, we are a design, drafting, and survey firm, and we're licensed in 12 states. We're also proud to announce that DDSI is celebrating its 20-year anniversary this year. Our headquarters is in Tulsa, Oklahoma. Then we also have field offices here in Denver, Colorado, Carlsbad, New Mexico, and in Midland, Texas. Our groups oversee anywhere between 20 to 30 field crews collecting survey accurate data pretty much on a daily basis. We primarily work in the oil and gas industry, where we provide survey services to all phases of construction to midstream operators. This includes preliminary routing, staking, landowner plats, plus as-built and after-built data capture. In the wireless telecom space, we partner with architecture and engineering companies responsible for installing new wireless infrastructure. We provide the exhibit and easement documentations to get the projects approved by the local municipalities. And some of these projects are the new site builds, rooftop surveys, and easement designations. We also work with civil engineering firms for our commercial and residential projects. These include ALTAs, land survey plats, and survey grade data for remodels and new construction. So here's a brief overview of some of the technology employed for this presentation. So the software that we were using for these projects, it was ArcGIS Online, Esri's ArcMap, ArcGIS Pro, and AutoCAD Civil 3D. The mobile apps were Collector for ArcGIS and EOS Tools Pro. The RTK Global Navigation Satellite System, or the GNSS, was the Aero Gold receiver by EOS. The laser rangefinder was the TruePulse 200X by Laser Technologies, and the real-time correction we were using was a virtual reference station setup. The data collectors were the iPad Mini 4 Pro, Samsung S9, and ToughPad running Windows 10. So for our first case study, I'm going to be showing how we implemented the Collector, EOS, and LTI's laser offset routine to save us some time in the field. So what we're looking at here is a lease area for an existing wireless monopole design. The scope of work for this project was to survey the existing monopole. We needed to tie down the parcel boundary, then as-build the compound here, capture all third-party utility locates, produce a licensed surveyor stamped exhibit, and then a legally binding document in order to add any additional access and utility easements to potentially increase the number of wireless providers and further add bandwidth for this location. As you can see here, this is the full project site with the wireless lease area highlighted in the yellow. Our number one goal in the field is to capture all the required assets and features as accurately and quickly as possible. So in our business, we really aren't able to do like a pre-recon of the site. We're not able to go out there ahead of time to the project location to kind of see what issues might arise once we get there. So it's important to note that most of these types of projects are issued a fixed fee for us as a contract. So it's up to us on our end to figure out where the efficiencies can be built in and where time savings can be captured. We need to be ready to implement all the tools in our toolbox at any time to solve a problem. And this is where the collector, EOS, and LTI laser offset workflow has really begun to make an impact and save time spent in the field, which for us is our most costly line item to manage. So what we're looking at here is a close-up of the lease area from our high-resolution drone imagery. Contained within this site is a variety of equipment that needs to be captured by our field crews, including any existing concrete pads and structures, the H-frames that hold the wireless-specific hardware, so over here and over here. Of course, the tower itself, any handholds where fiber optic splices can be accessed. And then for our demonstration, the underground utilities located by a private locator that we partner with, marked in the red for electric, orange for comms, blues for the water, and yellows for gas, and greens for sewer. Typically, we have our drafters add these locates right from our imagery, especially when you have a clear view of skies, like kind of like what we're looking at right here. But what if you can't see your assets? So here's an example. We ran into this project where essentially a group of tightly spaced utilities were obstructed by dense vegetation. As you can see here in the yellow boxes, a group of electrical and communication pedestals were all clustered together here, but only 2 could be seen from the imagery. Here in the ground level photo, you can see that 5 or 6 of the boxes that have separate utilities running into each one of them. So over down here, you see the flags where all that was marked up. So before utilizing the collector, EOS, and LTI offset routine, our workflow was to capture a bunch of point features and field sketches, then turn those over to our drafters for them to pretty much make sense on their own. That left a lot of room for error, then a slew of questions for our field crews and project managers. Questions from our drafters equal time, time equals loss of profit margins. So as you can see here, there's quite a bit going on in this picture. There's a bunch of flags, some orange paint, then some faint blue, some yellow paint markers that don't really show up in this picture. And you can only really figure out what was going on when you're standing directly over the top of it. This is typically when we'd pull out our total station to begin collecting points and start adding our field sketch to help explain what was going on here. Notice the location of the 3 locate flags, and we'll come back to these here shortly. So with the total station, there's definitely some pros and cons. Pros, it absolutely has its purpose for creating high accuracy offsets. The data can be post-processed, which allows our licensed surveyor to authenticate its accuracy. Some of the cons, calibration time. Backsites and multiple checkpoints need to be created to establish and ensure accuracy. It typically requires both of our field crew members to essentially stop what they're doing in order to operate. This entire process of setup, calibrating, checking in and checking out of the data, then multiply that by multiple locations, and that workflow really begins into our fixed budget. So as Sarah touched on earlier, there are 3 supported workflows within Collector and the EOS Tools Pro using LTI's laser rangefinders. The first is the range azimuth. This uses the standard laser offset using the True Pulse 360. Since the True Pulse 360 already has essentially an azimuth or a compass built into it, you're able to take multiple points without having to occupy 2 control points. The range solution, which is what we're going to be talking about today, is a triangulation solution that uses the True Pulse 200X via Bluetooth. The range azimuth backsite, which uses the same 200X rangefinder, but it also pairs up with LTI's true angle mounting system. This allows the system to acquire the necessary angle calculations without having to occupy multiple points. So essentially, you can set up in one location without having to do the triangulation and collect many points from the same spot. So this is where the Collector, EOS, and LTI laser offset routine has been a huge time saver for us. When we utilize the range offset routine, one field crew member can now capture our visibly obstructed assets very quickly and accurately without having to stop what they were doing, switch gears to a different piece of equipment. We can go ahead and move to where we have a clear view of sky, obtain 2 accurate control points, and produce the required laser offset. So here's those same flags that we can see over here. Here's those pedestals that were obstructed by that same tree. So here you can see how easy it is to start the laser offset routine from inside Collector for ArcGIS. The first step of the routine is now included out of the box within Collector, allowing us to quickly acquire the required control points and then accurately capture the offset of the asset. Notice the location of the control point safely occupied outside the dense vegetation cover and the approximate location of that same point. From there, the workflow moves over to the EOS Tools Pro app, where once both the control points and the laser offset shots have been captured, the intuitive range intersection selection screen allows immediate feedback for which offset point is correct, and then be able to be submitted and saved to ArcGIS Online. This once again saves us time and allows for quick quality control in the field. And this will be able to be performed by a single crew member. This also provides the decimeter accuracy, which is essentially less than 4 inches, that we need to create our final deliverable. You can see the 3 points, which were highlighted in that previous slide right here, pretty much showing up exactly in their same location where they were posted. We then create the correct utility polyline features from those offsets in the field, whether it's a fiber optic cable, a water, a gas line, etc., and store those into our hosted ArcGIS Online account. This eliminates the guesswork back in the office from only a multitude of points being turned over to our drafting department, sometimes in one of our other offices, which was our workflow before implementing this new offset data capture process. So you can see here where we've got the triangulation. You know, this is the screenshots that we took in the field, so it showed up exactly right where we were looking for it. It gave us immediate feedback from the field, allowing us to know right away which was the correct point to use. We knew that it was the right location. We also have to collect utility building attachments. So depending on their location, our previous solution was to place the survey pole directly against the building and essentially hope for the best. That would typically cause multipath errors plus mislocating the features, and we wouldn't be able to figure it out until we got back to the office. Or we'd add these features to our field sketch, which would then require both field crew members to stop what they were doing. We'd actually physically pull measuring tape and then log those distances in our field book to then be passed on to the drafters to interpret and add to the deliverable. We now implement the Collector, EOS, and LTI offset routine to complete the same task, essentially at a fraction of the time. Here are the screenshots from those same building attachments in the previous slide. Once again, inside the EOS Tools Pro app, the range intersection selection screen provides immediate feedback showing the offset point in the correct location, allowing the field crew members to quickly QC the data, know the building attachment is the right location, and then submit and save to ArcGIS Online. One thing to note here is the accuracy of the offset point captured on top of the base maps for both EOS Tools Pro and inside of Collector for ArcGIS. So when I started deploying some field data collection projects, managing your base layers took a lot of time and effort, but pretty much not anymore. I can't stress how helpful it is to have these accurate base maps, even when you're offline, to give a sense of general location to your field crews, no matter where your location is. And while we were initially capturing this offset point, there was once again some partial vegetation over here by this first control point. Once we got to the range intersection selection screen, we could immediately tell that the laser received some interference from some of the bushes adjacent to the building, and the intersection point was nowhere near the edge of the building as shown here, and we knew we had to recapture the offset to get the correct location. So with the combination of both base maps, the accurate feedback provided in EOS Tools Pro, we didn't have to wait to get back to the office to figure out that the point was inaccurate and needed to be thrown out. So yeah, you can see here how it shows up right next to in these base maps, which is a huge help. So as most of us are aware, Esri provides multiple ways for users to manage their data. We choose to host our Collector for ArcGIS projects in our ArcGIS Online account, thus allowing our other office staff to be able to view and retrieve the data in just about whatever format they need. ArcGIS Online allows for the multiple ETL formats to extract, transform, or load options without having to use another third-party software. Since most of our final deliverables are drafted in AutoCAD, Civil 3D, being able to directly download a shapefile or even in a CSV, for example, without having separate staff members process the data saves us even more time. So here we're looking at a mesh of all the data captured from this project, digitized and processed. The survey accurate parcel boundary is tied down. Utilities located here by the EOS collector and LTI offset solution. Easements drafted from the client provided title commitment. 1-foot contours extracted from our post-processed drone data, all laid on top of our high-resolution imagery, also collected by a drone and viewed in ArcGIS Pro. Here's just another blow-up of that same view with some additional details to be displayed. You guys can kind of see a little bit extra of how this all came together. From there, we added any additional access and utility easements requested by the client to further build out the lease area. They can then turn over this final deliverable to the local municipality with our stamp and signature from one of our licensed surveyor for review and approval of the project. So this next project I want to quickly talk about is a recent survey we completed at a local city park. The scope of work included capturing all existing features and spot elevations in a 25-foot grid and at each sidewalk entrance. We also were required to collect the privately located utilities, irrigation sprinkler heads, and valve control boxes for approximately a 5-acre location. The purpose for us was to be able to turn over the deliverable and data to an architecture firm for them to design new ADA compliant ramps and overall park improvements. As we talked about before, we're never quite sure what we're going to find until we get there. And this turned out to be another situation where collector, EOS, and LTI laser offset solution became the perfect tool for the job. Notice once again, we've got some densely vegetation locations here on the park. Once we got on site, there were quite a few irrigation valves and sprinkler heads that were within the obstructed areas. In this specific scenario, you can see the irrigation head was heavily obstructed for us to be able to physically occupy the point. But just 10 yards away with a clear view of the sky, we were able to perform the offset routine without having to stop, switch gears, and potentially use our total station to acquire the single point feature. From the picture on the right, you can easily tell how obstructed the receiver was to the clear view of sky, now allowing us to capture the point and stay within the client's required accuracy thresholds. The second example is from the northeast corner of the park, and you can see about the same dense canopy obscuring the clear view by these pine trees. We could have tried to stay in the same location, potentially trying to average 30 to 40 points and hope for the best. But why chance it? By once again, we can step out on the clearing, allowing us to gain a fixed VRS position with sub-inch control accuracy, then perform the laser offset routine. Our single crew member was able to solve the problem without having to stop, reassess, and potentially ask for help to acquire the single point feature. Once again, here's all the point features and underground utilities we collected with our collector, EOS, and LTI offset solution overlaid in ArcGIS Pro. Within our highlighted area, you can see how far back that irrigation head really was. It looked deceiving from the previous photo where it kind of looked much closer to the southern edge of that location. By being able to collect the located utilities and all irrigation features, then posted to ArcGIS Online, then brought directly into AutoCAD for Civil 3D by a simple shapefile download was a huge time savings for us. The less hand-holding by our project managers and field crews have to do with our drafters, producer deliverables, typically can mean a difference with whether or not a project is profitable or not. Here's a screenshot of the final deliverable required by our client with the stamp and signature, and you can see here where the level of detail was necessary. By using the collector, EOS, and LTI offset routine, we were able to deliver this project on time and under budget. Very quickly, this is the last project I want to talk to you guys about. This is a recently completed a couple weeks ago for one of our engineering clients. All the points you see here in magenta were captured using our total station to be able to post-process and deliver engineering quality data for their design purposes. The utility locates once again captured by our collector, EOS, and LTI laser offset routine, including an entire set of offsets to create the common fiber polyline here at the southern end where it was obstructed by thick rows of trees and bushes. So to do the quick data comparison, I captured 2 points, one physically occupied and then the other as a laser offset to QC the data back in the office to kind of do my own Pepsi challenge. As you can see from the physically occupied point, we got less than an inch of error from the same point collected from our total station. It's well within the range of GPS error, GNSS error, and the possibility of the survey route was not held perfectly plumb. And then the laser offset, where we shot the same back curve location, was sub-decimeter accuracy for the offset, so less than 4 inches. So I know this is not truly a scientific test, and I'm sure I could have gotten even more accurate results by doing additional testing. but to be completely honest, we ran out of time. The point is, though, if you're looking to collect your own assets and are able to tie into a base station or virtual reference station, getting sub-inch real-time, no post-processing accuracy has now become a reality for everyone. Here's just a quick screenshot of the accuracies that we were getting when we were tied into our virtual reference station. Note the horizontal, vertical being put out by Collector for ArcGIS, and then inside of EOS Tools Pro. And as the technology of the GNSS satellites continue to evolve, this is just only going to get better. Quickly want to note that a host of GNSS and laser offset fields are now available out of the box in ArcGIS Pro. You can add this toolbox to catalog in ArcGIS Pro, run the scripts to your desired feature class within your geodatabase, and you'll see these automatically populated when data is captured in the field. Quick recap, tight budgets for us require a little room for error. Every project site is unique, requiring different tools. There's continual field challenges that we don't know until we get on site, whether it's urban corridors or dense vegetation. Collect accurate data with only one crew member is a huge key for us. Being able to bring your own device and to tie into Esri's apps to solve problems on our fly are also been a huge time saver. The RTK laser mapping acquires the high accuracy points that we're looking for, allowing us to get the final deliverable on time and under budget. Once again, I'd just like to thank everyone at Esri and EOS Positioning for inviting me to participate in this webinar today. Hopefully this has piqued a few ideas on how you can implement this type of field collection workflow to ideally quickly solve some data capture problems, of course, save some time and money within your organization. With that, I'd like to pass it back on to Mark and begin the question and answer portion. Thanks, everyone.
So, Mike, the project, I love that outside warehouse, if that's what you want to call it. I half expected a junkyard dog to be chasing you guys around that.
It was that, yes.
On that project in particular, what was the greatest value of, of the setup that you had? You did a lot of work in that little space there.
For sure. So, as I kind of touched on, it really comes down to time saved on both ends, from both in the field and in the office. The other key is the ease of use and the ability for me to get even some of our most junior field crew operators up to speed quickly. This whole workflow takes very little training, very little time to get set up, and it can be essentially passed on to anybody and anyone in your organization. And it's all contained within the same setup. So once you get it essentially configured, attached to your pole, you can head out and you're off and running in no time.
So what are the parts and pieces? Let's go over them.
Well, you have the receiver set up, and then you need to attach and calibrate your 200x offset for your rangefinder.
Okay.
And then tie that all together with your data collector. For our case, we use the iPad. It's just it's the most functional usage for all the software that ties into it. And then once you get all those set up with your survey pole set up, you can begin project in essentially little time.
Well, I'm familiar with total stations and other expensive technologies, but this just seems so much more agile.
It is, for sure. It's way more agile. What I like best about it is that even as you're physically occupying the points that are in clear view, you get to that situation where you're under a canopy or it's under a building, you run the offset and collect the 2 points from the outside, and shows up right up against the building in the base maps, save it, and move on to the next point.
Doug, I'll go back to you. You had mentioned something, I think all of you touched on different levels of accuracy from 1 centimeter to about 10 centimeters. And it's not clear to me, what is the difference in the setup to get better accuracy, or is it the method in which you shoot your points with multiple control points or such? What's the causing that variability?
Mark, that's a great question. So a lot of that boils down to the setup. As Sarah outlined, there were 3 different methods. Some of those do have more accurate calibrations with an angle encoder, so you can get a very precise angle for that offset, and obviously also the distance in which you're shooting, although for most cases the laser rangefinders that LaserTech provides are quite accurate. So those are just a couple of factors that can influence the level of accuracy of a position you would capture with this solution.
Okay, that makes a lot of sense. Let's see, one question, this might also be for you, Sarah, asking to talk a little bit about virtual base station.
Yeah, I would actually pass this on to Mike because he has more field experience using it.
Front Range of Denver, we are essentially blessed by having 2 openly facing municipality provided virtual reference stations. So these are not available everywhere. So you'd have to check where you're located at to see if it's a possibility. But here we have 2 gracious local governments that openly face a virtual reference station that you can then tie in through the setup routine in EOS Tools Pro and Collector for ArcGIS to essentially put in the IP address and the port. And once you have that set up and you tie into it with a data connection, so whether that be a tie-in from whether your data collector has its own wireless connection or you hotspot it to your Wi-Fi hotspot, once you have that set up, then you receive those offsets, and that gives you that essentially centimeter accuracy on the fly. So you'd have to check in your local area if that's available. If not, there are some paid services out there that you can look at, but I wouldn't be able to speak on which ones are available in each area. But in Denver, we have those that are openly facing.
Yeah, Denver is a very it's a good place to be if you want to do this kind of work. If you're curious what's available in your area, if you fill out the EOS contact page on our website and you're specifically curious, is there an RTK network? Is there a VRS? Is there something in your area? Just ask us and we can probably find somebody in that area.
You know, almost glossed over what sounded like a crazy level of productivity increase here, where 2 people would have to go out with rather expensive hardware. Crew of 2 is now going out and doing 2 projects. 100% improvement in productivity. I mean, is that really what you're seeing?
For us, the ultimate goal is to complete 2 sites per day. For our 20% return on investment, for us, essentially that goes down to being, at minimum, it's saving us at least 2 hours in the field per project. And then it can take us anywhere between 2 to 10 hours for each one of our project sites to draft back in the office. So we're saving another 2 hours on the office for the drafters by eliminating the hand-holding with the questions, where we've got the high-resolution imagery in the background. So instead of just turning over essentially a bunch of points on a blank screen and then asking our drafters to figure that out and create those deliverables that I was highlighting, this whole workflow has essentially saved us that 20%.
Yeah, that's probably being conservative.
Yeah, pretty much, yeah.
You know, we're going to close this off. Thank you for the fantastic presentations, Mike, Doug, and Sarah. And thanks for those who joined us today. Thanks for your participation. This concludes the program.